we can just try something that initially seems like it's doomed to fail. Um, but I just want to try it anyway, because if it fails, we learn new
Yeah.
stuff, or we can come up with new ideas along the way. Especially when it's a bit vague, it's just a fun idea that we just see if we can get there. Um, and if we don't, almost 10 out of 10 times there is something else that arises from that just by trying.
Hey, everybody. I'm Jonathan from Autodesk. Welcome to Shop Talk, the podcast series where we get together with makers, designers, engineers, and inventors to talk shop. Today, we spoke with John Shoen from Proper Printing. John's projects are a series of experiments involving electronics, 3D printing, mechanical engineering, manual processes, and he puts all this stuff together to make compelling content on YouTube that's also really informative. Let's dive in. All right, John Schoen from Proper Printing. Thanks for coming, man.
Thanks for having me.
So I guess first things first, can you tell us, aside from just being Dutch, how did you get into design and engineering?
I think it was in when I worked at Philips, and then I started at Philips, and at Philips I came in touch with 3D printing,
Huh.
and it was back in the day when the first the Ultimaker One came out, the wooden
Yeah.
things. It was in the development environment there, and they were just placing them, several of them, all over the the company there, just saying, just play around with them and see what you can come up with. Um, a lot of people were printing this, some aesthetic things like this typical owl of the Eiffel Tower, and I was working on a test system for shavers. Long story short, I believe that I am one of the first that actually used 3D printing in a functional way at Philips, where I
Nice.
made 3D printed jigs to mount shavers on there, so we could do some tests on it. And that's what basically got the ball rolling of going into 3D printing. Like, okay, you can do a lot with this stuff.
Yeah, interesting. So I'm not surprised by that really because you can see in your work this kind of comfort with with experimenting. I think that those of us that got into 3D printing when it was still kind of experimental, where like, this like you said, that first Ultimaker was made out of laser cut plywood, right?
Yeah,
There was a lot of tinkering going on. You kind of had to modify your own machines to get them to behave in a way you wanted. You had to play around with the firmware and like understand G code a little bit to be able to make things work. So yeah, that makes a lot of sense that you have that background.
I think the tinkering part is what I learned at Philips. There was this group that was called Game Changing Innovations. It, unfortunately, it's not there anymore, but it was an eye opener where a lot of people, and their job was just to come up with new and exciting ideas, just as far out of the box as possible. Of course, it must be within the what fits with the products of Philips, so within the shaving or coffee or whatever. And I also had some ideas that I pitched to them, and they were like, they were weird ideas. I cannot talk about them, but they were okay. We're going to try that and see what happens. And that's also the mindset that I try to show in my videos as well, because a lot of people do expect some final working product. Like there must be a reason why this is done and it should work. But I try to show that we can just try something that initially seems like it's doomed to fail. But I just want to try it anyway, because if it fails, we learn new
Yeah.
stuff, or we can come up with new ideas along the way. Especially when it's a bit vague, it's just a fun idea that we just see if we can get there. Um, and if we don't, almost 10 out of 10 times there is something else that arises from that just by trying. And that's what I like about 3D printing, is that you can afford a mindset like this. You don't have expensive machine hours or dies or whatever. It's very cheap and affordable to just start iterating, and yeah, it's not that risky.
Could you tell us a little bit about the like education system in the Netherlands and how that kind of helped track you into where you are, or if you kind of bucked tradition a little bit and just went off on your own. Um, I know it's fairly common in Northern Europe to sort of have a track system where
Hmm.
when you're maybe like in around high school, you start taking aptitude tests, and then they kind of basically give you a track to go in. So
Yeah,
is it similar there? I'm not really familiar with how it works in the Netherlands.
it's pretty similar. You start off with just the generic stuff, and when I was 15, I made the decision to go more to a practical
Yeah.
practical education. So the, the the broad stuff was a lot of language and the stuff that I wasn't very good at. Um, but I didn't. Of course, school helped a lot, but it didn't suit me that well. I finished it, but I was probably one of the least motivated people there. I always, well, school is like this. You have um, a task, it's very specific set of drawings. I'm talking about the precision engineering school. We get a set of drawings, and we had to make that. Or we got a very specific project, like a chess set, or a what's it called, a pipe cutter. Pipe cutter was basically was a very interesting project. Lots of but you have this task, but someone else came up with that, and I never liked doing it. I just did it to
Mhm.
get my a good grade, or just good enough that I can continue. But I always I found motivation in trying my own stuff, and I was very happy that I just did the stuff that I had to do as fast as possible, so I had time left to do my own stuff. So I back in the day I was modifying PCs, and we had milling machines and everything, so I had my own material. I brought it to school, and made my own stuff with it, and that's the only thing that really excited me. And that's what troubles me with school, but I also don't know how you can do it better. That I if someone else came up with the idea and I just have to do it in, well, in the way of, well, how it's expected, no, I don't get motivated. So I always try to do come up with my own ideas. So that's what I like about doing YouTube, is that I'm now capable of coming up with my own ideas.
So you went from, I guess, I mean, it sounds like maybe you were salaried at Philips. It sounds like you had a pretty clear career track, but then you just decided to go off on your own and start making content and experimenting and inventing new ways to do 3D printing.
Mhm.
Can you tell us about that? I mean, did you transition into this being a viable career?
It wasn't at Philips. I worked at Philips for 3 years, and then I worked at a smaller electronics manufacturer. They're called Varias. It's they produce industrial electronics, and I was a test developer there. So we produced test systems to automatically test the PCBs. Um, and I started with, well, I at home. I think that a lot of technical people also have hobbies at home. So I did a lot of that stuff, and I I thought that it's a shame that I keep this stuff to myself. So I had this feeling that, okay, I want to share this somehow. And I bought a very cheap camera, a secondhand $50 camera, and said to myself, um, I'm going to record YouTube videos with that. And if I ever hit 1,000 subscribers, then I'm going to buy myself a better camera, and then this YouTube thing might be something for me. So I did that besides my full-time job at Varias. You can see, if you look at my very first videos, they are all, the quality is pretty bad. It's all done on that very cheap camera. Um, but it proved me that it's about the content and not about the gear. Something that I have to remind myself of often, because now I'm more of a gear nerd and I want to have better gear. Um, and I think that that helped with just starting out. Then I bought my first DSLR, the Canon 80D, um, and a better lens, and made more serious videos, bigger projects. And I started working less for my day job, from 40 hours to 32 and then to 20. And
Mhm.
eventually, I think it was last year, May last year, I just quit my
Yeah.
job and went full time for YouTube. And I was very lucky with my boss. He is also an entrepreneur, and he said that he was just pushing me like, do it. He didn't want to get rid of me, but he understood my situation and he was just cheering me. So that
Yeah.
was really nice.
Yeah. I mean, it's impressive. I mean, to go from, like you said, a $50 camera to where you are now. I mean, the quality of your content is really high. It looks great.
Thanks.
But I mean, the most impressive thing about your work, really, I think it's just, it makes sense to me now that you've explained your background, because the work you're doing really is that intersection between mechanical engineering, electrical engineering, and then just kind of this inventor mindset, right? Um, all the 3D printing experiments you've done, the extruder that you came up with, which is really cool. Just these really cool little simple ideas, like the tensioning system for the trusses for your 3D printer. You've got this kind of tinkerer attitude that I think serves you really well. I'd never seen anybody do that before, right? Like where you drilled a couple holes in a little machine screw, and then you thread this fishing line through it or whatever it is, right? And then
Hmm.
you're just kind of, I don't know, just yeah, trying things over and over again until you get to something that's useful. Was the goal? So I'm going to talk for a minute about the lamp project and some of the projects that preceded that. Um, was it intentional that the idea was that you would solve some problems that would help you make this kind of revolutionary 3D printer with the dual head? Or were those things like, was it kind of happenstance that you learned some things with those projects, and then that informed what happened with the 3D
Um,
printer?
it's the latter.
Yeah.
I had this idea that, well, with the trusses, well, it came with it started with the you have these truss gantries.
Yeah.
They're milled and for the extremely fast 3D printing.
Yeah.
Um, I don't know how, but I had this sort of vision that it should be possible to have them in individual segments, tension them, and then to me it seemed like it should be very stiff and light. And then that's basically the whole thought process behind it. Um, and I wanted to build a printer with that. Initially, the idea was to build a Core XY, just a Voron style printer, all out
Hmm.
of this truss material, but it very quickly became too much. And time was running out, and I wanted to make at least a video with that system, with some sort of deliverable, what you can do with it. And I came up with this lamp, and halfway the video, I wanted to ditch it. I was thinking about ditching it. Like, who cares about the desk lamp? And then it turned out to be my most successful video. Now my second most successful video. So I never expected that. That was a lot of fun. Um, yeah, but and for the printer, because it is a moving portal, it it really helps when the portal itself is as light as possible. Otherwise, it will um, wobble too much.
Hmm.
So, but I didn't think about that when I came up with the truss idea. It basically just came together while I was working on this stuff.
Yeah. Yeah. Well, that's that's really cool. I mean, uh, it's that's really kind of where invention comes from, isn't it? You tinker with things and experiment, and then you start getting ideas about how else you could use this thing you discovered. A big question that comes up all the time is, how do you come up with your ideas, right?
Hmm.
And I think
Yeah,
the most straightforward answer for most people is that they sort of spontaneously happen. Like once you start working on something, you get ideas as you're solving that problem, whatever that particular thing is. And before you know it, you've got a backlog of things you want to try that you'll never get through, right?
exactly. Yeah, when I started the channel, I had one idea,
Yeah.
and that was I had the old CR10, and I found it very cumbersome to replace
Yeah.
the nozzle. So I thought maybe I can make a system that can just disconnect the whole thing.
Yeah.
And that was based off of the tripod that I was using, very old tripod. So it's basically a very old tripod system, quick tool change system. And then it was like, okay, now I have this loose tool. It should also be possible to add a laser engraver on there, and then the next problem arose is that I had to somehow disconnect it. So I came up with the idea to make a sort of connector there that can disconnect all the wiring. And then the
Yeah.
second problem came with, okay, I also want to disconnect the Bowden tube because it wasn't a direct drive. And I had this experience with from the electronics with these mixed sub-D connectors, and they are also pneumatic. So like 1 and 1 is 2, maybe I can just disconnect the Bowden tube with a mixed sub-D connector. And then the next step came, maybe I can 3D print this sub-D connector. Oh, if I can print this connector, then maybe I can incorporate other 3D printed features within this connector. And now I'm already 5 or 6 videos in.
Yeah.
While I started with this single idea, and that was such a fun process to go through, and I never expected this to happen when I started out.
I was curious, in that video you mentioned Project Escher, which is something we developed at Autodesk maybe, I don't know, this was probably 8 years ago now. And I was there while the research team was working on that, right? And it was,
that's cool.
Yeah, it was really cool watching these guys. Some very smart and talented people spent, a solid year or two on that project. If you're not familiar, it was this really big multi-head FFF 3D printer, right? I'm just curious about why did you pursue that in the first place? What was the point of having a dual head 3D printer with independent print heads?
It was this problem, I think 2 years prior, maybe 3 even, where I tried to 3D print a rim for a car out of ABS. It was a fun use case or fun deliverable for the video, but the idea behind that was that I wanted to gain experience with printing big parts out of difficult to print materials. So I wanted to go a level higher with the engineering materials. I figured I start with ABS, that's already pretty hard. And I managed to print a 7 kilo part this big. Well, I have it here.
Oh, good. You've got it.
This big.
Yeah. Nice.
Well, this is half of it because it got damaged. But this was, and the next version, the next iteration was stronger and a lot bigger. I printed that warp free on a CR10S5. And the thing is that it needs an enclosure.
Yeah.
So the CR10S5 has a build volume of 500 by 500 millimeters.
Yeah.
And it's a bed slinger. So if you want to build an enclosure for it, it has to be at least a meter deep.
Yeah.
And I already ordered that printer. And then I thought, okay, that is going to be a problem. So while I was looking at the actual picture of my order successful, I thought, I think it should be possible to just move the portal back and forth and have the bed stationary. With the only reason to save space. So there were a lot of comments saying, oh, it's going to wobble, and you can mitigate that by adding a second belt on the top and everything. I didn't do that. But that was the only reason, because I needed to build an enclosure and not to be this big. I didn't know about Core XY, so I think that's a good thing. Otherwise, I would have just stayed within that mindset. But the moving portal system was born. Some portal milling machines do the same, and when I was working on that grill plate printer with the individual portals, I still want to make to experiment with different materials. So I needed a machine with multiple tools. And then this moving portal system came to mind again. I think I should be able to add more portals to it. And that's how it basically came to be, that I can maybe add another portal. And if I can, then they can move individually from each other. So it was also a bit poking towards the IDEX system, because that's called an independent dual extrusion system, but there's not much independent. They are just independent in one axis. So therefore I came up with the idea of the time system, the true independent multiple extrusion.
Yeah.
With the idea that, okay, next step could be to add more and more portals, and I think I pitched this idea to someone, and he said this is a lot like the Autodesk Azure project. So I haven't
Yeah.
seen that project, and then I saw that was, oh yeah, it's very similar.
Yeah.
So yeah, that's how basically my thought process went, and the story behind this.
Yeah. Well, one of the advantages of it, I'm sure you had this in mind, is that if you've got two independent printers, you can have, so if you imagine the build plate, right? So you want to do something that's long, it could be wide too, but in this case, let's just think of it as something that's longer than what you could print on a normal print bed, twice as long, right? What they ended up doing with it is you could do the big reason behind it was speed for larger things. So
Yeah.
they can be printing stuff independently, and then they cross over each other in the middle. It's almost like it's stitched together, right? And then but they can be running independently as you go. So you don't have to take all the time to do this whole huge thing with one print head. You've got two kind of crossing over each other. So in theory, you could, speed it up by almost 50%.
Yeah.
Have you experimented with that yet? I mean, the software behind this has got to be really complicated.
But to be very honest, my main goal behind this machine is to experiment with totally different materials. And with totally different, I don't mean ABS and TPU, but I mean PLA with a layer of an adhesive, like a glue
Sure.
between the layers, or add concrete as an infill material to make parts heavier. Those kinds of combinations is what I want to do. And I recently realized that it would make, for these types of experiments, would make a lot of sense to try and do that on the Prusa XL with a tool change system. So I have 5 independent materials. So that's my goal for this year, is to see if I can really start experimenting on a Prusa XL
Yeah.
for the goal of really experimenting with these materials and not the parallel printing. So I think that is for some people, it's a bit of a maybe a bummer that I'm not continuing with this the time system in the near future, but it's still there as a platform for future things to print literally in parallel. But it's I think it's less interesting than the weird material combinations that I want to experiment with. And that was
Okay.
what I had planned for this time machine, but
Yeah.
I think a tool change makes more sense for it.
So then the advantage there of having those independent portals, as you call them, for radically different materials, is that just because you could have a print head on the gantry that's much larger, for example, like as opposed to if you were to use the Prusa XL? Is
Yeah,
that kind of the idea there? Like why that would be advantageous?
I didn't see a lot of advantages besides it is a novelty, it is an idea, just
Yeah.
as we have discussed earlier, is that this was an idea that I wanted to try out
Yeah.
with the multiple material possibility in mind. But there aren't, if you only look at multi-material, then there aren't a lot of advantages as compared to something like a Prusa XL. The
Sure.
only thing I can think of is that it might be a bit faster because the XL has to grab a different tool. And with this system, you can swap
Yeah.
quicker between the two.
Yeah.
But that's a diminishing
That's
advantage.
a very small advantage, I'd imagine.
Yeah.
That Prusa XL is really fast getting those
Yes.
new print heads out. Do you have one?
Yes. Yeah. And I
Good.
just, yes.
Yeah.
And also for the people, I think that for the viewer, it's also more interesting if I start experimenting with the Excel,
Yeah.
because it is a printer on the market you can
Yeah, they
buy.
could buy one.
And I will not recommend trying to replicate the printer I built.
Yeah.
I'm also not going to build a second one. It's a
Yeah.
one-off, and it should be a one-off.
Well, it's super entertaining, and again, you've learned so much from it. Like who
Yeah,
knows where those pieces are going to come together later. You know,
exactly.
I think a big mistake a lot of times people make. You see this in startup companies, but you also see it in just independent inventors. Um, we tend to get obsessed with an idea and just stuck with it because it really a lot of times it's just a sunk cost fallacy. You think in your head, I've invested so much in this dual head 3D printer and it's got so much potential and I'm just going to keep banging my head against the wall to try to get it to work. And instead of just kind of saying I've learned a lot from this, it's time to pivot to something else that's also interesting to me and just kind of trust your own talents and your own work ethic to make something new happen. That's a great attitude. That's really cool.
Thanks. Also nice to formulate it this way. I
Yeah.
haven't done that myself.
Let's see. And then I wanted to also ask about other manufacturing methods that you're interested in. It's there we can all see you with your manual mill, doing simple tasks with that to kind of, to put a part together. But are you considering a larger CNC machine, like kind of getting into that world at all? Because what you start finding there, it's like a whole world opens up that you didn't see before, where you
Yeah,
start thinking in terms of, oh, that should be a CNC part. Like that's a way better,
yeah,
part for that. You're already doing that with laser cutting and 3D printing, right? Like
yeah.
you think in terms, okay, well, this needs to be a flat sheet that makes a lot more sense for this particular part. A 3D thing, sure, of course I'm going to 3D print that, but then you start getting into questions about strength and durability and the plastic just can't handle the forces that metal can. It's just, it's basic physics, right?
Yeah.
So then you start thinking about that as another tool, and yeah, I think you'd do some amazing stuff if you had that in your repertoire too.
Thanks. Yeah, what I like about, well, now you mentioned laser cutting, is that you have to think differently.
Yeah.
With each process, you have to think about how it's eventually machined or how it's produced. And I think that that's one of the most interesting aspects of designing stuff. You have a lot of freedom with 3D printing, but even with 3D printing, you have this problem. But what I like about laser cutting is that you have to think in 2 dimensions and how to make 2-dimensional parts combine in such a way that you get a 3-dimensional shape.
Yeah.
So I had this, I don't have the original extruder here with me, but the extruder I developed, I 3D printed it first, and it looked like it should be possible to make this fully out of laser cut parts. So I redesigned the whole thing from the ground up using only laser cut parts and off the shelf parts. And it's such a fun experience, it's such a fun learning experience to set these restrictions and try to design around it. And what it turned out to be, well, the idea was to have an extruder, if I eventually turn it into a product, to have it in sheets of plywood or
Yeah.
whatever, and you can just pop out
Yeah.
the
Yeah.
parts. So you can send an extruder in an envelope, except for the motor.
Yeah.
But I think that would have been a cool concept, but it didn't work. Well, I did sort of work, but it was a subpar extruder. But what it ended up being, and I have this example here, um, is that it eventually turned, I'm not sure how clear it is, but into a 3D printed part again, but
Uh-huh.
with all um, the simplifications that forced me to implement because of the laser cut part. So
Yeah.
now it's back to 3D printing, but now I only added the features that can only be done with 3D printing, but with the simplicity of the laser cutting. What I have here is a hot glue gun with the extruder on top.
Yeah.
Um,
Yeah. Yeah. I
and
love
that's
it.
what's one of the things that we mentioned earlier is that you can, if you have an inspiration or a new idea, then you can maybe combine that with one of the older ideas. And this one was because of Stefan from CNC Kitchen.
Mhm.
He showed how he 3D printed with hot glue sticks.
Uh-huh.
Well, yeah, with hot glue sticks, but he grinded them first and then
Right.
turned it into filament.
Made a filament. Yeah.
Yeah, and when I watched that video, I was like, I think that I should be able to just modify my extruder and print with the sticks. So that turned into the well, I'm going to do this. This is an awesome video idea, and it works. So this was a fun project that was inspired by by an external factor, but
Yeah.
it combined with an old idea of this extruder.
I love that project because when I talk to people who don't know what 3D printing is, I usually just tell them, imagine a hot glue gun on a robot arm, right?
Yeah,
It's basically the same thing. It's cool to see somebody actually make that and it actually works.
it isn't hypothetical anymore.
Yeah. Do
So
you have
this
any
is
other artifact? Yeah.
the benchy. This
Oh,
is
yeah. You made a benchy
pure
with it.
pure
Nice.
hot glue benchy.
That looks pretty good.
I have to mention that there was a lot of stringing here, so
Uh-huh.
I removed all the stringing, and it scaled up. But yeah, cooling was a bit of an issue. But yeah, it has a weird feel. I took this with me to the Sanjay Mortimer Rap Rap Festival in
Uh-huh.
December last year. And everyone was like, "Oh, this feels so weird. It feels like it's sticky, but
Uh-huh.
it doesn't, and it doesn't stick. It has a very odd texture to it. So that was fun to see people's reactions.
I love it. What material is that? Like what is a glue stick? Is it PVA?
I know it. I don't know by heart. I looked it
Yeah.
up, but it wasn't very clear. I think there are also multiple blends.
Yeah. There's a lot of different kinds you can get for sure.
Yeah,
Yeah, that's
yeah.
interesting.
And
Um,
also, by the way, this subscribe sign behind me is all hot glue sticks, but with different
ah,
colors.
nice. How did you get the colors? Did you dye them beforehand
No,
or
you can
buy
just
them?
buy glitter hot glue sticks with
Oh, of
each
course.
color.
Right.
I didn't know that, but when you start diving deep into the hot glue world, then there's also engineering grade stuff. It's insane what's out there. I have another example here. It's also this was a very talking about design challenges. Is
Yeah.
the 3D printed shoe.
I was hoping you'd have that. Yeah.
Yeah, this is the one out of sort of flexible wood. This is the aesthetic that I was going for, and eventually printed it out of TPU.
Uh-huh.
Mm. And this is the one that I actually wore to Form Next for the whole day, and
Yeah.
yeah,
Uncomfortable?
was uncomfortable. Yeah. Um, the biggest problem is with well, this edge was a bit sharp, so that was going to hurt.
Yeah.
But usually with shoes, they will form around your foot. But when using TPU, your foot has to form around your shoe,
Yep.
and that's painful.
Yeah.
Um, but what I liked about this project, it's also, well, I'm an engineer. I'm used to parametric design with the AutoCAD background and Inventor and everything. Um, and I approached this from this engineering perspective from the parametric design. So I tried to, well, basically the sole, the outer sole is fully made with the call it conventional methods, extruding stuff, finding the tensioned curves, and so for I don't know, it's even a bit twisted. So this was a very challenging to pull off
Yeah.
with just the extrusions and fillets and whatnot. But with the shoe, that was just that it wasn't not possible. I can tell you that that's not possible. So I was very happy to see that Fusion does have a surface
Yeah.
modeling feature, and that worked all right.
Yeah.
I had to go into a whole different mindset. I have
Yeah.
this mindset of being exact, having dimensions, and now and also be able to have well, you have a timeline, so you don't want to do things and then undo them again. You want to go back in the timeline. But with surface modeling, is that I'm going to pull a bit here and then push a bit there.
Yep.
And you have to let go of a lot of things that are
Yeah.
so baked in. But that's
Definitely.
what's nice about Fusion is that it has this well, it has all inside of this one software. So yeah, really felt like I opened up a new skill, and now I can also do some surface modeling in there. So that was really cool.
Yeah, surface modeling, I don't know, it's more like sculpting.
Yeah,
And you kind of just have to get into that mindset about it. I'm not very good at that. Like it's hard for me to let go of the spreadsheet, right? Like this
yeah,
dimension is this dimension is this, all that stuff. Like I don't know. It's yeah, you kind of have to force yourself into it, right?
yeah, yeah. And that's nice about. I always shied away from that, but that's nice about trying stuff like this is that I, in order to get this to work, there wasn't another option.
Yep.
So I had to somehow. I didn't need to use Fusion per se, but I needed to do this surface modeling technique, and Fusion is a software that I'm already used to, so it was a logical step. Um,
Yeah.
but yeah, it's nice to have a project to, and that's I think how I learned most of my skills is to have a project on the tip of the horizon and work my way towards it and need to do things that I'm not good at in order to reach that result. And I think that most of my skills are acquired by, and this is a perfect example of um, yeah, on how I learn new things.
Sure. Do you have any other artifacts you want to show before we move on?
Yes, I have a few here. One
Okay.
is another benchy, and
Uh-huh.
this is it doesn't look like the best benchy in the world, but this is printed out of resin, but on a standard FDM printer.
Whoa.
So this
Let me see
is
that.
a it's a combination of um, resin with, I think this is with glass bubbles. I'm not sure anymore. Um, but I did this by um, I made a peristaltic pump that didn't pulsate as much, and I pumped resin through a sort of a silicone tube, same
Oh,
diameter as a regular Bowden tube, um, through a standard 3D printer nozzle, and I had two UV lasers pointing at it, and it was
whoa.
curing at the tip of the nozzle.
That's crazy.
So this was a very cursed project. But this is one of the things I also want to try in the Prusa XL again with
Yeah.
the material combinations.
Good way to ruin your printer. I like it.
Oh yes. Oh yes.
Sounds
I don't
messy.
want to get near to that printer anymore. And another project is also an old one. This was a very interesting one. Is the 3D printed guitar neck. Um, we all know that 3D printed guitars exist, but they always 3D print the body and put a normal
And a
neck on
wooden
it.
neck. Yeah, yeah.
And I wanted to do it the other way around, have just a regular body. And I think that this is the part that is the most well the most toughest part. Um, so the interesting what I really like is how the threads look in this plastic. It has a very weird look to it.
Yeah.
It was much harder to press in threads than I expected, but um,
Oh,
and
so they're not printed in place. You pressed them in separately.
I pressed them in with a thread pressing call, and
Okay.
yeah, that
Yeah.
was really cool. And what I encountered eventually, and it did show that in the video, is that this head is starting to, because of the tension in the strings.
Yeah.
This is made out of PLA, and now even the strings aren't touching the nut anymore.
Uh-huh.
Um, but this was still, I want to 3D print a whole guitar. But with this, now I know that this problem exists, and I have ideas to actually solve that. So this was a very cool project to do, and this neck was printed on a belt printer.
All right, so we'll give you the closing question here. So the big idea is that the zombie apocalypse has happened, and you need to start over, rebuilding your shop and helping rebuild civilization. So what tool do you get first, considering you put yourself at great personal risk to leave your compound?
Yeah, I must say that this was a very tough question. Um, so I would start stealing solar panels. We have a lot of them in the fields, and I reckon that these will still work. And I assume that the grid is not existent anymore.
Yeah.
So I have to make my own energy, electricity. So I'll steal solar panels and car batteries. And I see that as the perfect opportunity to have my whole studio or my whole shop run at 48 volts instead of just 48 volts DC instead of the 230 AC or 110 in the US.
Yeah.
Most of my equipment eventually runs on a lower DC power, so I can run my 3D printers again and continue iterating and work on a better society. So that
Yeah.
would be my strategy.
I
Start
like it.
stealing car batteries and solar panels.
That's good. Yeah, good answer. Start at the beginning. How do I power this thing? Yeah, you don't think about that a whole lot. Like if you look into what people do with camper vans or cabins, that kind of thing, you start to realize how many low voltage solutions there really are for things. I mean, the
Yeah,
only reason we really use AC is because it's much easier to transmit over long distances, right?
yeah,
Whereas if you've got a localized power source, if you've got solar panels and a battery bank or something like that, very few things actually need high power like that, like maybe a clothes dryer or a oven or
yeah.
something.
Yeah,
Yeah.
and I think that if you are in this situation of the apocalypse, um, then I would just use fire for warming up
For heat.
food
Yeah.
and heat. Yeah, so
Yeah.
heat is the biggest problem with this low energy or low voltage stuff, because
Yep.
if you have a 2 kilowatt heater running at 24 or 48 volts, you need very thick wires.
Yeah.
But yeah, you can just start burning the stuff. Start burning zombies. I think there is a lot of energy in there.
Sounds smelly.
Um, yeah, and smelly, but yeah, you do that outside. Well, the whole world will probably be already very smelly.
Yeah,
But
good
yeah, I
call.
can get my 3D printer running on 24 volts, so I will be fine.
I love it. Well, cool, man. Thanks for coming, John. It's great talking to you. I'm sure the audience is gonna love it.
Thanks, Jonathan, for having me. It was an awesome chat.
Hey everyone, don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things Shop Talk. If you're ready to try Fusion 3 yourself, find the link in our description.